Hello and welcome dear students again in today's class. So today we will continue our chapter metal and non-metal. So let's begin this class without wasting our time. Okay students, so here we are on the next slide. Now we will talk about chemical properties of metals and non-metals. Okay, in the previous lecture we saw the physical property of metal and non-metal, and we had also seen the difference between the physical properties between metal and non-metal. But now we will talk about the chemical properties. So the first chemical property of metal and non-metal is that I am differentiating between the chemical properties of metal and non-metal. Here I am writing the properties of metal, and here I am writing the chemical properties of non-metal. So the first property or the chemical property of metal is that they generally have 1, 2 or 3 electrons in their last orbit. Generally have 1, 2 or 3 electrons in their last orbit. 3 electrons in their last orbit. Or you can also say that they have 1, 2 or 3 valence electrons. Now, if I talk about metals, then they generally have 5, 6 or 7 electrons. 5, 6, 7 electrons in their last orbit. So guys, this is the first difference between the non-metal and the metal. So why I am telling you this? So for making you understand, let me take you to the next slide. Okay students, so here let's take some examples of metal. Let's suppose I have sodium, okay, which electron number is 11. Okay, let's take the other example of metal. Let's suppose I am taking magnesium, and the electronic number for magnesium is 12. Now we have aluminium as well. Aluminium, and electronic number of aluminium is 13. So guys, if I write the electronic configuration of sodium, then I will be writing 2, 8 and 1. And if I write the electronic configuration of magnesium, then I will write 2, 8 and 2. Okay. And what about aluminium? This will be 2, 8 and 3. Now guys, this is the case of metal. This is the case of metal. Now, what about non-metal? So let me write some of the examples of non-metal. So let's suppose guys, we have, let me change the pen, we have phosphorus. Phosphorus is a non-metal. So what is the electronic configuration? Electronic number of phosphorus is 15. And what about electronic configuration? It will be 2, 8 and 5. Let's suppose that we have sulfur as well, whose electronic number is 16. And what is the electronic configuration? It will become 2, 8 and 6. And what about chlorine? So the electronic number for chlorine is 17 and electronic configuration is 2, 8 and 7. Now guys, you might be thinking that why I am writing it. So basically, I just want you to know that you can see that sodium has one electron in the last orbit. Okay, and this magnesium has 2 electron in the last orbit and aluminium has 3 electron in the last orbit. So here we have written the same thing. What we have written? We have written that metals generally have 1, 2 or 3 electron in their last orbit. So you can also see on this slide, then sodium has 1 electron, magnesium has 2 electron and aluminium has 3 electron in its last orbit. Okay, now guys, what about the non-metal? So we had written that non-metal generally have 5, 6 and 7 electron in last orbit. So you can see by some of the examples of non-metals that they have 5, 6 and 7 electron in their last orbit. Okay, so I hope guys this basic thing is clear to you. Now after understanding this, let's talk about the another point of this. So let's see. Okay students, so here we are on that previous slide. Now the second thing is that metals are electron donor. Metals are electron donor and non-metals are electron acceptor. Now to prove my point, let me again take you to the next slide. So basically guys, you can see that the sodium has electronic configuration of 2, 8 and 1. So I am writing this sodium here, 2, 8 and 1. Okay, now this chlorine has the electronic configuration is 2, 8 and 7. 2, 8 and 7. Now guys, what will happen? These two will come closer. These two will come closer because they both want to complete their octet. So what will they do? To complete their octet, this sodium will give its electron or will transfer its electron to this chlorine. Transfer its electron to this chlorine, and after the transfer of electron, this Na will become positive. The positive charge will come. Why? Because it donates its 1 electron. So that's why it will become cation. What will it become? It will become cation. Let me write it here. Sodium cation. Okay. What does it mean? It means that it is positive. And what about this chlorine? So as we all know that sodium has given its electron to this chlorine, so it will become negative. And for negative, we use this term anion. Chloride anion. For positive, we use cation, but for negative, we use this anion. So this is negative ion and cation is positive ion. So guys, as you can see that positive charge will attract the negative charge. Chlorine has become negative and this is become positive. So they will attract each other and they will form a molecule of an ACl. An ACl molecule is formed. Okay, And how does it form? Because of the electron transfer by the sodium. Okay, so this NaCl molecule is formed. I hope guys this formation of NaCl is clear to you. So here you can say this compound or this molecule of NaCl, which is formed by the transfer of electron, will be known as ionic compound. This is ionic compound. So what are the ionic compounds? So the compounds which is formed by the transfer of electron are known as ionic compound. So I hope guys this thing is clear to you that what is ionic compound. Now guys, why did I tell you this? So I wanted to prove this point that metals are electron donor. On the other hand, non-metals are electron acceptor. So here you can see that this metal sodium donate its electron and chlorine has accepted this electron. So that's why non-metals are basically electron acceptor. On the other hand, the metals are electron donor. So this is the second point. Now let me write the another point as well. So point number third is that metals form cations. Metal forms cations. And what are the cations? Cations are the positive ions. On the other hand, non-metal forms anion, or you can call it negative ion. Negative ion. So guys, here you can see that this is the sodium cation and this Cl minus is chloride anion. So we can conclude that metals forms cation and non-metals form anion. Okay, now guys, this metal is forming this positive ion. That's why these are called electropositive element. Okay, this will be known as electropositive element. Electropositive element. On the other hand, these non-metals are forming negative ion. That's why it is known as electronegative element. Electronegative element. So I hope guys these points which are written on this slide have been clear to you. So guys, now let's move on to the next slide. So here we will talk about the reaction with oxygen. Okay, so basically guys, we all know that when it will react with oxygen, then it will form metallic oxides. So here it is written that metal reacts with oxygen to form metal oxide. When copper is heated, it combines with oxygen to form copper oxide. This is an example. You can see that copper is reacting with this oxygen and it is forming copper oxide. Okay, so this happens with all the metals. They react with oxygen and they form metal oxide. So guys, most of the metal oxide are basic in nature. Metal oxides are what? Basic in nature. On the other hand, the non-metallic oxide are acidic in nature. Okay, non-metal oxide are acidic in nature. So here you can see This copper oxide is what? This is metal oxide. So it is basic in nature. And why these are bases? Because when it reacts with water, it will form bases. Okay, and I will be giving you some examples as well. So let me tell you some examples that how these act as an base. So let's move on to the next slide to understand this. Okay students, so here we are. When aluminium is heated, it combines with oxygen to form aluminium oxide. So this is again the reaction of metal with oxygen. You can see aluminium is reacting with this oxygen and aluminium oxide is formed. Now the same thing which we have seen, that some metal oxides are basic oxide because they react with water to form bases. Now here some of the reactions are given. So you can see here that sodium is reacting with oxygen and sodium oxide is formed. Okay, sodium is reacting with oxygen and sodium oxide is formed. Now when this sodium oxide react with water, then it will form sodium hydroxide, which is a base. This is what? This is a base. Okay, so that's why, because it is forming a base, then we can conclude that metallic oxide are basic in nature. Okay, if you are not able to understand by this example, then we can take another example as well, that potassium is reacting with oxygen and it is forming K2O, which is potassium oxide. Let me write it here. This is potassium oxide. So when this potassium oxide is reacting with water, then it is forming KOH, which is potassium hydroxide, and this is again a base. This is again a base. So we can say that because the metallic oxide forms bases in water, that's why we can say that these are basic in nature. Okay, I hope guys this basic point is clear to you. We can also write some other examples as well. Let's suppose calcium oxide is reacting with water. When it reacts with water, then it will form CaOH whole twice. This is a very famous reaction. When we were studying acid, base and salt chapter, that time we had seen this reaction. Okay, this is basically slaked lime. Okay, and this is lime. Now guys, let's talk about the other example also. MgO. This is what? This is magnesium oxide. When this reacts with water, then it will also form magnesium hydroxide, which is again a base. This is milk of magnesia. We also already discussed it in acid, base and salt chapter. So guys, these are some of the examples which shows us that metallic oxide are basic in nature. But guys, there are some exceptions as well. We will talk about those exceptions on the upcoming slide, because not all the metallic oxide are basic. Some are showing both the natures. Now I will be telling you when they will show acidic nature and when they show basic nature on the next slide. So let's move ahead. Okay students, so here we are. Now you can see that this Al2O3, this is aluminum oxide. Al2O3 is what? This is aluminum oxide. So this is amphoteric in nature. This is amphoteric in nature. Amphoteric nature. Now what does this mean? Basically guys, it means that it will show both the nature, acidic plus basic. Now there are other examples as well. ZNO. This ZNO is what? This is zinc oxide. So this zinc oxide is also an example of amphoteric oxide because it will also show acidic and basic both the behaviors. Now guys, we will see that when it show the acidic nature and when it will show the basic nature. So first of all, you all know that when HCl reacts with NaOH, then it will form NaCl plus water. Okay, so we can say that if acid reacts with base, then it will form salt plus water. Let's suppose if there is a compound X is showing this property, because when it reacts with base it is forming salt and water, then definitely that compound will be acidic. And let's suppose if a compound Y is reacting with acid and it is forming again salt and water, then we will call this compound Y a basic compound. Why? Because it is forming salt and water, and we all know that only bases show this property, that whenever they react with acid they form salt and water. That's why this Y must be basic in nature. So guys, you can see in this reaction where Al2O3 is showing this reaction. It is reacting with HCl and it is forming AlCl3, which is aluminum chloride. Okay, and also it is forming water. So that's mean that this Al2O3 is basic in nature. Now on the other hand, when it is reacting with NaOH, then it is forming an NaAlO2, which is a salt, and also it is forming water. So it means here it is acting as a acid. It is acting as a acid. So you can see then when this Al2O3 is reacting with strong acid, then it is acting as a base and forming salt and water. And when this Al2O3 is reacting with a base, then it is again forming salt and water. So here it is behaving as a acid. So we can conclude that in front of a strong acid it will behave as a base, and in front of a strong base it will behave as a acid. Okay, so I hope guys by these above reactions you might have been able to understand that why Al2O3 is amphoteric. Why Al2O3 is amphoteric, because it is showing both the behavior. And when it will show basic behavior, when it is reacting with a strong acid. And when does it show the acidic behavior? So it will show acidic behavior when it react with a base or a strong base. So I hope guys this basic thing is clear to you. So these are the chemical properties of metals. Okay students, so now here we are. Here we will talk about the reactivity of different metals with oxygen. Okay, so basically guys, all metals react with oxygen differently. So if I talk about metals like potassium and sodium, so these metals will react vigorously with oxygen, and it will catch fire if it kept in open, because they will react with the oxygen present in the outside in the surrounding. So that's why it is stored in kerosene to prevent burning. These metals are stored in kerosene to prevent burning. So let me write the equation for the reaction of sodium with oxygen. So if this sodium will react with oxygen, then it will form sodium oxide. Now let me balance this reaction. So here, as you can see, two atoms of sodium is present, and here only one atom is present. Here two atom of oxygen is present, and here only one atom of oxygen is present. So if I multiply here with 2, so you can see the number of oxygen on both the sides is equal now. Here also the number of oxygen is 2, and on the right side also the number of oxygen is 2. But the number of sodium is not balanced. Why? Because the number of atom here is 2, but here only one sodium atom is present. So what will I have to do? I will have to multiply this sodium by 4, because here as you can see, the number of sodium atoms is 4 after multiplying with 2. Okay, when I didn't multiply it with 2, the number of sodium atom was 2. But when I multiply here with 2, the number of sodium atom will become 2 multiplied by 2, and that is 4. So to balance the sodium atom, I have added this 4. I have multiplied here with 4. So now you can see this equation become balanced. The number of oxygen is 2 on both the sides, and the number of sodium is 4 on both the sides. I hope guys this point is clear to you. Now magnesium burns with a bright flame. If it reacts with oxygen, then it will be burning with a bright flame. So let me write down the equation for magnesium. So if magnesium reacts with oxygen, it will form magnesium oxide. Now this is also not balanced. So to balance this equation, I will have to multiply here with 2. So now you can see oxygen is balanced on both the sides, but magnesium is not balanced. So if I multiply here with 2, now this equation is completely balanced, because on both the sides all the atoms are equal. Here 2 magnesium atom is present, here also there is 2 magnesium, here 2 oxygen atom is present, here also there is 2 oxygen atom. I hope guys this point is also clear. Now if I talk about iron, so iron is heated and it is glowing brightly. It is glowing brightly. So if I have to write down the equation for iron, then this will be Fe plus O2, and it will form Fe2O3. This is basically iron oxide. Okay, now this equation is also not balanced. So what will I have to do? If I want to balance this equation, then I will multiply here with 2. Okay, now after multiplying here with 2, I will have to multiply here with 3. So if I multiply here with 3, so you can see the number of oxygen is equal. Here 6 number of atoms of oxygen is present, and here also 6 number of atom of oxygen is present. But the number of Fe is not balanced, because here 4 atoms are present of Fe, but here only 1 atom is present. So what will I have to do? I will have to multiply here with 4. So after multiplying here with 4, you can see that this equation or this reaction became balanced. 4 Fe atoms here, and here also there is 4 Fe atoms. Here on the left side 6 oxygen atoms, and here on the right side there is 6 oxygen atoms. So I hope guys these equations, these reactions are clear to you. If it is clear to you, so let's move on to the next slide. Okay, so here we are. If copper is heated, it doesn't burn but forms a black coating of copper oxide. So basically when you react copper, or you can say when copper reacts with oxygen, then it will not burn, but it will form a black coating of copper oxide. So let me write the equation here, CuO. Okay, and here also you can see that copper is reacting with oxygen. Now silver and gold doesn't react with oxygen. It is very important even at high temperature, because I told you that gold is a noble metal. Okay, so they do not react with anything very easily. So even at high temperature, they do not react with oxygen. Now, there is one very interesting point, and that is there are some metals like magnesium and aluminum and zinc and lead. So these type of metals, what do it do? Basically, guys, so the metals like magnesium, aluminum and zinc and lead, these metals, what do they do? Basically, guys, they form with oxygen, or they react with oxygen, and they will form a oxide layer. They will form an oxide layer, and this oxide layer prevent the further oxidation. Okay, so these metals are known as self-protecting metals. Let me write it here. These are known as self-protecting metals. And why are we calling it self-protecting metals? Because they are preventing itself to be further oxidized. So that's why it is known as self-protecting metals. So I hope, guys, the reaction of the metals with oxygen is clear to you. Now, after understanding this, let's move ahead on the next slide. Okay, guys, so we are here, and here we will talk about some of the examples. So you can see the first question: what are the self-protecting metals? So, as I told you, that self-protecting metals are the metals which preventing the further oxidation. Okay, they will form a layer of oxide, and then this layer prevented from further oxidation. So those are known as self-protecting metals like aluminum, okay, and magnesium. So these are known as self-protecting metals. Now let's talk about the second example. Give two examples of amphoteric metallic oxide. So guys, we all know that what are the amphoteric metallic oxide, which shows both the nature, acidic nature as well as basic nature. So if you are asked some of the example, then zinc oxide, okay, aluminum oxide, these are the examples of amphoteric metallic oxide. Now guys, let's talk about the third question, and that is, what is aquaresia? So basically guys, aquaresia is a mixture, or it is a freshly prepared mixture of concentrated HCl and concentrated HNO3, which is nitric acid, and this is hydrochloric acid. Now you have to mix it in a ratio of 3:1. Okay, you have to take 3 parts of HCl and 1 part of HNO3. So this mixture is known as aquaresia, and this is used to melt the gold. This is used or to dissolve the gold, because if you use this alone concentrated HCl, then you will not be able to dissolve gold. You have to use this mixture where 3 parts of HCl is mixed with 1 part of nitric acid, and it will become aquaresia. Now it has the ability to dissolve our gold. So I hope, guys, the examples which we have discussed here are clear to you. So thank you so much, guys. Now I'm ending this lecture, and we will meet in the upcoming lectures. Till then, thank you so much, and bye bye.